Okay, let's start the lecture again. We were calculating SS dash, okay? S dash phi, that's equal to S phi S dash phi, but S phi is same as T phi and S dash phi is same as T dash phi. So which is equal to T dash phi. So that means the pair SS dash TD dash, it belongs to rho, which is your kernel of phi. Okay, so therefore rho is a confidence. Rho is a confidence. ये इसका पहला पार्ट था. Rho is a confidence. Now we need to show that there is a monomorphism alpha from S over kernel of phi to T. And now let's define alpha from S over kernel of phi, that's equal to rho, to T by let's take the rho class, its image under alpha. So it should be in T, but we know that phi is a map from S to T, so I should write here X phi. So define this map, and we will show that this alpha is a monomorphism. It's a monomorphism. So we prove it's well defined as well as monomorphism simultaneously. We prove alpha is well defined and one simultaneously. So let's choose two elements from S over rho such that they are equal, and we'll show that they are equal if and only their images are equal. So which proves well definedness and one-oneness simultaneously. We prove alpha is well defined and one simultaneously. So let X rho and Y rho be two elements as a rho such that X rho is equal to Y rho, and this is true if and only if image of X under phi is same as image of Y under phi. They must be same. So that means actually XY, it belongs to rho. It belongs to rho if and only if, which is true if and only if they are rho related. Okay, they are rho related. It implies that what do we mean by rho related? So it means that what's rho? Rho is actually kernel of phi. So it means that X phi is equal to Y phi, and which is true if and only if X phi is equal to X rho alpha is equal to Y rho alpha. So X rho is equal to Y rho if and only if image of X rho and Y rho under alpha is same. So that means this alpha is well defined and one. Now we prove it's a morphism. Now we show that this alpha is a morphism, is a morphism. So again we must choose two elements. So let's choose two elements. X rho, Y rho belongs to S over rho. Then image of X rho, Y rho under alpha, by definition of the product of rho classes, it's X, Y rho, its image under alpha, but image of X rho under alpha is X phi, so here it's X, Y phi, and this phi is a morphism. It is X phi y phi. And what's x phi? It's x rho alpha, then y rho alpha. So therefore alpha is a morphism. Alpha is a morphism. Hence alpha is monomorphism because it's also 1 1. Therefore alpha is a morphism. Hence alpha is monomorphism. Hence alpha is monomorphism. Therefore alpha is a morphism. Hence alpha is a monomorphism. Alpha is a monomorphism. Next we show that image of alpha is equal to image of phi. It follows from the definition. It follows from the definition. It follows from the definition of alpha as x rho of alpha is equal to x phi. So image of alpha, okay, it's same as image of phi. If you choose any element in image of phi, so that's of this type of x phi, so which is equal to x rho phi, so which is in the image of alpha actually. And if you choose any element in the image of alpha, that's of the form of x rho alpha, which is equal to x phi, so that element belongs to the image of phi. So it follows from the definition actually. Finally we show that the diagram commutes. Finally we show that this rho natural alpha, this should be equal to phi. Rho natural alpha is equal to phi. So domains of both the mappings are S. Okay, let's choose any element in S. Let x belongs to S. Then we have this, okay, x rho natural alpha, this is equal to x rho natural, then you apply alpha. But what's the image of x under rho natural? That's the rho class of x of alpha. But what's x rho of alpha? This is equal to x phi for all x in S. So which means that rho natural alpha is equal to phi. So hence the theorem is proved. Theorem is proved. So this was theorem number 2. Now we have theorem number 3. हमें वो सारी होमोमॉर्फिज्म की थ्योरम्स करनी जो ना ग्रुप्स में हम करते हैं वो यहाँ पर सारी करनी है. तो यहाँ पर नॉर्मल सबग्रुप की जगह पर कॉन्ग्रुएंस है. ओके, Now theorem number 3. Let rho be a congruence. Let rho be a congruence on a semigroup S. Let rho be a congruence on a semigroup S, and let phi from S to T be a morphism such that this rho is subset of kernel of phi. Rho is subset of kernel of phi. Then there is a unique morphism unique morphism one minute. Then there is a unique unique morphism then there is a unique morphism beta from S over root T such that image of beta is equal to image of phi. Image of beta is equal to image of phi, and such that the diagram commutes, and such that the diagram commutes. And the diagram is the following. We have S, we have T here, and we have morphism phi between S and T, and we have here S over rho. Rho is a congruence, and this is the rho natural map, and there is a unique beta, this thing, from S over rho to T, such that image of beta is equal to image of phi. And this diagram commutes means that the composition rho natural beta is equal to phi. So this is actually generalization of previous theorem. In particular, if we take this rho equal to kernel of phi, because rho is any congruent subset of kernel of phi. So in particular, if we choose rho equal to kernel of phi, then we will get a map. Then this will get a map from S over kernel of phi to T बीटा है ना, बीटा हमें मिल जाएगी, हमें प्रीवियस थ्योरम में मिली थी अल्फा, S over kernel of phi to T. So it's some sort of generalization of theorem number 2. Okay, this we define beta. We need to define this beta. This beta should be unique, and this beta should commute our diagram. Proof. So let's we define beta by, we define this beta by beta. Okay, it's from right down the domain here, S over rho to T by x rho of beta is equal to x phi. जैसे हमने उसमें किया था ना डिफाइन, सेम. X rho beta is equal to x phi. So first we verify that this beta is well defined. Beta is well defined. For this, let's choose two elements in S over rho such that they are equal. We need to show that their images are also equal. So let x rho y rho belongs to S over rho such that x rho is equal to y rho. Okay, so we prove their images are equal. So this means that x y belongs to rho, but rho is subset of kernel of phi. So they are in kernel of phi, which means that x phi is equal to y phi by definition of kernel of phi. But what's x phi? It's x rho beta. X rho beta is equal to y rho beta. So whenever we have two equal elements in S over rho, x rho and y rho, then their images under beta, they are also equal. So that means our beta is well defined. Our beta is well defined. कैमरा सब लोग ऑन करिए. Okay, this beta is well defined. Now we show this beta is also morphism. Beta is a morphism. Beta is a, it's also simple. Beta is a morphism. So for this we again choose two elements, that x rho y rho belongs to S over rho. Then what's this? X rho y rho of beta, this is same as x by rho of beta, and which is equal to, by definition, x y phi, that's equal to x phi y phi, which is equal to x rho beta and y rho beta. So this beta is morphism. So also it's trivial that image of beta is same as image of phi. It follows from the definition of beta, from the definition of beta. So finally, next we show that this beta is unique and it commutes the diagram. First we verify that it commutes the diagram. It commutes diagram. Next we show that commutes diagram means that this row natural composition beta should be equal to 5. So let's choose any element of S, that x belongs to S, then x row natural of beta, it's equal to x row natural, image of x and a row natural of beta, but this thing is x row of beta, which is equal to x5. So therefore this it commutes diagram, row natural beta is equal to 5. Now we prove it's unique. Suppose there is another beta dash, which is a morphism and commutes the diagrams. Uniqueness of beta, okay? Uniqueness of beta. Suppose there exists beta dash, there exists a morphism, okay? It's right here. More beta dash from S over rho to T such that the diagram commutes, means that rho natural beta dash is equal to 5. We show that this beta is equal to beta dash. Beta is equal to beta dash. We show that beta is equal to beta dash. Beta is equal to beta dash. So what's these are the mappings on S over rho. So we choose an element from S over rho. Let x row belongs to S over rho. Then x row of beta, it should be equal to x row of beta dash, but this is equal to x row natural beta by definition. This is equal to x of row natural composition beta, but row natural composition beta is 5, and this 5 is again it's equal to row natural beta dash, because beta dash has the same property, and this is again equal to x row of beta dash. So that's this beta is equal to beta dash. This proves the theorem completely. अब इसमें थ्योरम एक है, थ्योरम नंबर 4, वो आपके लिए असाइनमेंट में रखूँगा. आई विल स्टेट दैट थ्योरम हियर. उसमें ये थ्योरम 3 यूज होगी. लेट रो एंड सिग्मा, लेट रो एंड सिग्मा बी मॉर्फिज्म be morphisms on a semigroup S. On a semigroup S such that rho is subset of sigma. Rho is subset of sigma. Then we have then rho over sigma, which is equal to this set. It's a relation on relation on S over rho. Okay, it's x rho, y rho, x rho class of x, rho class of y, which is in S over rho cross S over rho. This relation on S over rho, such that this xy belongs to sigma. Okay, and what's this actually, this rho over sigma? It's actually, इसने यहाँ पर explain किया है इसको अच्छी तरह से. So actually we have a map from S over rho to S over sigma, which is a morphism, that's beta. और इस morphism का जो kernel है ना, kernel of beta, this kernel of beta is a congruence on S over rho, and this kernel of beta is actually sigma over rho over sigma. Okay, rho over sigma. तो आपको प्रूव करना है this rho over sigma is equal to this, the kernel of beta, it's equal to this. So you need to show that this map, this relation on S over rho is a congruence. This is a congruence. This is a congruence. It's actually kernel of beta is a congruence on S over rho. Is a congruence on S over rho. Okay, and one more thing, that S over rho, that's very important. S over rho divided by, इसको आप फैक्टर करेंगे हम इसकी कॉन्ग्रुएंस से, जो इस पर कॉन्ग्रुएंस है. इस पर कौन सी कॉन्ग्रुएंस है? रो ओवर सिग्मा डिवाइडेड बाय रो ओवर सिग्मा. इट इज आइसोमॉर्फिक टू, ये देखिए रो और रो कैंसिल हो जाएगा. इट्स आइसोमॉर्फिक टू एस ओवर सिग्मा, जैसे नॉर्मल सब ग्रुप्स में होता है ना, जी ओवर एन डिवाइडेड बाय दिस एच ओवर एन इज आइसोमॉर्फिक टू जी ओवर एच. जो लास्ट थ्योरम है ना होमोमॉर्फिज्म की ग्रुप्स पर, इट्स सेम. It's like that theorem. S over rho divided by rho over sigma is isomorphic to S over rho. तो इसकी डिटेल्स है पेज नंबर 25. जस्ट 1 or 2 लाइन प्रूफ इसका है, वो आप देखिए एट पेज नंबर 25. कैन सी इन द प्रूफ. इसने पहले इसका प्रूफ दिया, इसके बाद इसका स्टेटमेंट लिखा है. ओके, तो वो आप देख लीजिए. अभी इस यूनिट पर समझो 2-3 लेक्चर्स है. दो लेक्चर्स, एटलीस्ट 2 लेक्चर्स.